Hi, Joyce. We are writing this down because on Friday we didn't get it written down. Gerardo ran to turn in his AP form. I reminded everybody, but they all got it done, and you probably did too, just in case you didn't do it today. Having too much fun this week. 10.4 and 10.5. It's technically both, and I think I gave you problems from both pages, but it's not going to be a super hard deal except for testing the endpoints. That might take a little time, and you have to review your 9 convergence divergence tests from chapter 10 intro. Don't worry though, you guys got this. When Gerardo gets back in, we'll peek at the calendar real fast. See how
Oh.
Yeah, he wasn't.
Are you mad that none of us noticed?
No one acknowledged it.
I might.
I was not back yet. But he's a bit soft.
You ran all the way.
He's gonna watch this
I should have texted you guys. I was standing right there and I was tempted to text you guys to put the volume up.
Were you really?
You knocked a little bit though, right?
Yeah!
I didn't even hear it.
Randall, why are you so red?
She's just laughing. She's funny. It was a sunburn. You didn't realize it.
There we go.
It's so
It
rude.
happened right now.
He's life though.
Wrong.
Okay,
Oh, I got a new black pen. I'm so happy.
go team. Is it a nice one?
Yes, it is, because my blue one was just annoying because the pen the inside kept coming out.
Okay, hey, you're behind the guy, right? Right.
Go on.
Okay, so at the very top, it's just a power series, right? No big deal. It's not technically a Taylor or Maclaurin because it doesn't have the derivatives written out per se. It's just saying, hey, it's some sort of power series with coefficients times x raised to powers. But of course, Taylor and Maclaurin fit under the power series category, as long as it's a series and not a polynomial. At the bottom, 2 main things for endeavor number 26. Oh, we are so close. I think we'll have 30. Yeah, I don't think we'll go above 30 unless we figure out something else we need to memorize.
But last year there was like 38.
Yeah, but we split things up differently. And they said things like L'Hôpital's because they hadn't covered it 2 years ago, but like we did cover it last year. So it's in our AP ones. Not in AP.
That is such a peeve.
I brought it in last year for the first time, I think. Like officially in AP notes. And then now, that was last year. And then this year it's actually on the AP exam. So it's good timing.
Oh, was it last year?
This is the first year it's like officially on there. Before, it might have just helped you remember things like, I don't know, horizontal asymptotes or limits to infinity a little bit easier. Okay, so we have interval of convergence. This does not have to just be alternating series. Now we still have the alternating series, error, remainder bound, blah, blah, blah. We still have geometric series. R has to be between -1 and 1. But now we can say interval of convergence for any power series, specifically. Any power series. And we just need to think ratio test, right? And that's what we saw on Friday. So ratio test, think of the n plus first term over the nth term. Absolute value needs to be less than 1, hence it needs to be between -1 and 1. The reason why we have this extra step, must test the endpoints for the interval, is because at the endpoints, when this limit equals, oh my goodness, I don't even know what just happened, sorry. Okay. When the limit equals 1 or -1, those are unknowns. The ratio test is inconclusive, hence we say we must check the endpoints. And what that means, when the limit equals 1, is we must use our convergence divergence tests. And you'll see why and how in our examples. So hang in there. But we must test the endpoints using convergence or divergence tests. If at the endpoint the series would converge, we say or equal to. If at the endpoint the series would diverge, we say nope, leave it less than or greater than depending on the context. And then last but not least, the radius of convergence says take the distance from one end of the interval of convergence to the other end and then cut in half. P.S. Real quick, what's half of 0?
0.
What's half of infinity?
Infinity.
Infinity, bingo. Important to know. Real quick before we continue class, just so we're all on the same track about what's going on this week. Tomorrow, AP Gov, I'm missing Amanda, and I'm missing George, and I'm missing anybody else? And other Amanda. Okay, so I'll have Jackie and Gerardo, and will Joyce be gone?
Yeah.
She'll be here.
No, should be more.
Oh, she'll be gone.
And Sam will be gone.
So, Sam does not have to watch the video, but Amanda and George and Joyce, if I were you, I would watch the video just to make sure we didn't do any makeover questions. But look at the calendar, because the nice thing is I delayed the test today. So, our goal today, technically 10-5, 10-4 and 5 is supposed to be due today, but instead it's going to be due tomorrow-ish, really more like Wednesday. Wednesday we're going to have the 10 review, but we can also go over questions on section 10, 4, and 5. But I'm thinking just to make things a little bit easier, we're going to go over the chapter 10 review Wednesday. Make sure you have that done. The packet you guys already have. I'm probably going to pick a few extra problems from the book just to give you extra chances for practice, and you guys can check them as you check all the other ones. I'll make sure to give you odds and not evens. So tomorrow is a work day on 10-5 questions. I'll probably let Gerardo and Jackie ask me some if they have any. If you guys have any, just text us, maybe as we're on the field trip or as we go in there or something. Or tonight, and be like, hey, can you check out these tomorrow? And we'll peek at them real fast. So that way, hopefully on Wednesday, we can go over the review packet itself. We can grade it real fast, go over questions you have, and then work on the book work. Does that sound good? So then test on Thursday, we'll have it all done. And no one's inquiring, no one's going to be gone. Good. Go team. Okay. I have, huh?
You guys gonna go to the concert on Saturday?
I'm going to try to do 6. Where are you guys' flyers?
They should be coming out tomorrow.
Okay.
And I'm gonna post this time.
There's going to be a basketball game if we were on
Oh,
I'm out of town.
Nice.
Ooh,
double
fun.
struggle. That is a really cool concert, though. That's one of my favorite ones. Hold on. Okay, section 10.4. I have it ready if anybody has started it, but we need to finish our notes first. So
Yesterday.
Me?
Totally forgot.
Okay. Oops, I'm marking on the notes. There we go. This one's easy. It's a McLaren series. One of the special ones we're supposed to have memorized.
Yeah, right.
Oh,
Yeah.
I don't have it memorized by the test on Thursday.
Well, yeah, but
Yeah, I like this one.
He's like the geometric series one, except he's divided by the factorials. So he's 1 plus x squared over 2 plus x cubed over 3 factorial or 6.
just the other test, are you gonna have like questions that's like find like you have like third power sine McLaren series, and you're gonna ask us to do the Lagrange error bound on like in like 6th derivative of sine. Just kind of pain.
It's better to be sine than to be one of the other ones.
True.
That's just sine, cosine, sine. Go find the 6th derivative. I'm not specifically planning on it, but I'll try to give you guys more information on Wednesday. I have to look at the test to make sure. Alright, so you guys expanding e to the x?
Just to the third is fine, right?
Yeah, that should be fine. What's the nth term?
Even Ronnie's x. Yeah.
Oh, right.
Is that okay?
As for certain.
Why is it good to have an nth term?
Just in case they want us to do
So we
it.
can take the limit and then put.
Yeah, to do the interval of convergence, we have to know the nth term, right? So the limit as n goes to where? Infinity?
Yes.
Now technically, does it make sense if I'm trying to find the interval of convergence and solve this limit? Even though we have done ratio tests before, I know. But why is it okay for me to do the n factorial over n plus 1 factorial separate from the absolute values and any of the terms involving x? Why is that okay? Why is that allowed?
It's multiplication.
Because
Commutative.
n doesn't go to
Multiplication and commutative we can switch around, but why does the absolute value not, why is it not needed on the left?
Oh, because from 0 to infinity.
Yeah.
And there's no numbers.
Yeah, and it can only be 0 or positive, so we're okay. Speaking of being okay, how would we simplify that limit?
It would be n. No, it would be 1 over n plus 1, right? And then x.
Mm-hmm. Is that true?
Yeah.
Right,
Ooh,
and
wait,
then
what's the
x
limit
here,
as n goes to infinity?
0. So 0, which is less than 1.
So 0 times anybody is 0?
Which is less than
So
1.
0 is less than 1 for all real numbers of x. Wait, so what can I say is the interval of convergence?
All the numbers. Or for 0 to 1.
We don't have to be limited by 0, that's only for n. So x is just from negative infinity to infinity, doesn't matter what x is. That's my interval of convergence. And didn't we already talk about how the Maclaurin for e to the x, sine of x, cosine of x are all real numbers?
Oh yeah, duh.
Now we have a reason why. But question, with that information, what's my radius?
Infinity.
Because half of infinity is infinity.
The
What if the interval was 0 to infinity, what's my radius?
Infinity.
Exactly. That's weird, but true.
Mine equals
Infinity over 2.
Exactly.
excuse me, man.
Ready, set? Let's see if we got this.
you know.
Let's just do A. Let's just do A for right now. In a second, we'll do B. Find the radius of convergence and the interval of convergence. Be sure to check the endpoints. Why? Don't worry, we're doing this one together. Then I'm going to set you guys through some B. Why, when I start doing the interval of convergence, am I going to totally ignore the negative 1 part?
Value.
Exactly. Okay, that backwards, don't it? Fail. 3 to 7, how are we doing?
One and a half. Because of when I was
2 to the n
Oh,
over 2 to the
no.
n plus 1. Now hold on, I'm not going to say IOC yet. I'm not even going to box it. I'm not going to do either of those things because I have to test one of the most common mistakes on these types of problems. So on FRQs or free response, if this shows up, there will be a point given for testing, not just the final answer. How do you test the endpoints? You consider what's going on at x equals 3 and x equals 7. How do I do that? I consider the original series. Does that make sense? Plugging in x is 3. Nice thing is we do have an alternating series. That might make things a little bit easier. 3 minus 5 is negative 2, right?
Usually the negative 2 again.
Plugging in 3. 3 minus 5 is negative 2. Seven minus 5 would be a positive 2. So how do we figure out convergence or divergence?
We have to do the alternating series stuff.
Almost, except careful on this one. Can't we pull that negative out? Can we pull that negative out? Wouldn't we
All of the different is just
need to multiply by another negative 1? When we multiply by another negative 1, what are we going to get? Adding the exponents, right? Now in this case it might not be a big deal, but other times it might be. Negative 1 to the n plus 2, plugging in 1, plugging in 2, plugging in 3. Oh, that is still going to alternate, right? Okay. So since it alternates and I have 1 over n, I can say, find the alternating series test. Maybe I shouldn't say this to you. The alternating series. Since the limit. This is where the convergence divergence do show up on FRQs. Quickly stating when testing the endpoints whether or not it converges or diverges. Since the limit as n goes to infinity of,
You just put a sub n.
yeah, if you want to you can say absolute value base of n just to say, be totally safe.
Do we have to put such that x equals 3?
No, it's okay. Because we're still in that same category, so I'm just kind of organizing it so you can tell. And series converges, right? How about the other side?
But is it it's conditionally, right?
True, but we can still say it converges at x equals 3. Does that make sense? Even though it's conditional. And at x equals 7. Very similar rationale. Series converges. So what am I going to say after all of that is my interval of convergence?
3 less than or equal to x less than or equal to 7.
Got it. Either use interval notation if you want with brackets, 3 to 7. You can use 3 less than or equal to x less than or equal to 7 and question what would my radius of convergence be.
5.
Got it. Does that make sense, kiddos? Kind of putting everything together. We might have to do our convergence divergence test. We're using our ratio test as our foundation basically for how we're doing interval convergence. So this one might be a
Is the
little.
radius 5 or is it 2?
Yeah, I was just thinking
Ooh, wait a minute. It's not negative 3, silly goose. I just said yes.
Not bad.
That's okay. 7 minus 3 is 4. 4 divided by 2 is 2. If you want, couldn't you be super snazzy and just say, hey, whatever, I'll never get it messed up? Just say 1 minus the other, cut it in half. But, yes, that would be 2. A box within a box. Okay, so, you guys, on your own, ready, set, go. I'm going to freeze it and I'm going to do it. Joyce, if you want, pause it. Done.
How did you do that?
Did you guys forget it was a geometric series?
Nice.
Woo! But what's going to happen when you do it the long way?
It's gonna be
I got-
bad.
I got X over 3 less than 1.
Yeah, that's what I was
Yeah.
Absolute value, then you would have had to do 1 to negative 1, right?
Yeah, so I was.
You were there.
So you just did the Geo series and saved yourself the hassle?
If it's a geo series, which the one on the left was not. Does that make sense?
We just have to prove it converted.
Mm-hmm. And I just stated geo series so that they did say justify. It's like, oh, I know what I'm doing. Geo series R is equal to X over 3. Got it. Why did we have to test the endpoints?
Because we know.
It's a geo series. It can't be 1 or negative 1. It meaning the radius. To be honest, I didn't mean to trick you quite that badly. I didn't even look at it and I started it. Is my radius right this time? Good. Let's see, do I have another one? Ooh, I have 2 more. Alright, now you can do it the long way.
Oh, sure, now we can do it.
Oh no.
Why? Because that's not a geo series, not even close, right?
Well.
Now I'm freezing it.
Misty, in the book, they called the homework problems power series, but they're not, because they don't come from the Geo series.
No. All power series are not geo series. Power series, remember at the beginning of notes, it was just a coefficient with x to an increasing power, which all of these are. Does that make sense? But the coefficients, as they get more complicated, well, they might not be geometric anymore. Kind of like how the special Maclaurens. There is a geometric series for 1 over 1 minus x, 1 over 1 plus x for the rational functions, but there's not a geometric series for e to the x or for sine of x or cosine of x.
Oh, that's hilarious.
Don't hear that one much.
Misty, I have my hand on my paper, and I ink fell on my finger, and I move my hand, and I stamp my paper. random sigma there. It's probably. Shucks.
You guys got it yet?
I think so. Jinx.
Because what happens to the limit? Got it. So it's going to be all real numbers. 0 is less than 1 for all values of x.
So, what is it?
It would have been x squared, but we didn't need it.
This is what happens when you do things.
Steve, how did you
Took me a lot
Get
of
this
mental
one?
work.
factorial?
Yeah, it took me a lot
Okay.
to figure that out.
But does it make sense my orientation, like why it's oriented the way it is? Okay. So then you have to think about with factorials. Let me zoom in on this real fast. This would be 2n plus 1, take away 1, 2n, take away 1, 2n minus 1, etc. So factorial.
We didn't test the endpoints.
On the bottom,
It's all real numbers. So you don't have to-
2n plus 3, take away 1, 2n plus, take away 1, 2, take away 1. See what I mean? Then you can go ahead and cancel those two out. Good question. Yeah, those factorials get a little tricky sometimes.
Why is it infinity to infinity for x squared less than 1?
Because of the 0, so 0 times anything is always 0, and 0 is less than 1. So if you want, I could have stated, oh, my poor little arrow got stuck. You know what I mean? So
Yeah.
0 times x squared is 0.
It's just confusing that like you're supposed to combine them in the end. So when you're finding the integral conversions, if it's like 1/2 times x squared. If like the limit equals 1/2.
I was gonna-
Well, we can't, but it's the limit as n goes to infinity, not x. So they are two separate things. You have to think about x as like an unrelated constant, in a sense. N is what is ever increasing. Does that make sense? So since you have n squared, or actually any power of n in the denominator, who cares what x is? X is a set constant given different series. As n increases, the whole thing's still going to go to 0. So, letter D. This is our last example. What? Go team. I'll just do it with it showing. You guys can go for it. Let's write it down first. Do it the whole way this time. Sorry, can you just parentheses from? That's just messy.
So, can you write no numbers? No.
So, divergent. just -1 to 1. It takes
How does that make sense?
that's the only time it's.
Is that-
But what if it's like 2? And it's -1, which makes it negative infinity, which is less than that. So it's less than 3.
Ooh, remember absolute value though.
But never mind.
The only time, think of it, it's centered at 3. Like the equation of a tangent line meets at a point and then it diverges, right? For an equation of a tangent line. For power series, it meets at a point, and then if it's converging, then it will converging over an interval. It'll get closer and closer and closer for set interval. This one, there is no interval, therefore it is only meeting at the center point. The center point being x equals 3. So think of it this way. X minus 3 times infinity, yes, it's infinity less than 1, but only when x is not 3. If x was equal to 3, it would just be 0, 0, 0, 0, 0, 0, 0, 0. So it would converge.
But I think 0 times infinity is indeterminate.
It is indeterminate, but look at the nature of the series if we plug in. So you can think about test at the endpoint, right? So 0 times infinity is indeterminate, so then we test at the endpoint. The only time that that will be true is if x equals 3. Or think of it this way, if you ever get what we could say is a non-existent interval, then there is no region around the center, which would be 3 in this case. There is no region for which it converges, therefore it will only converge at that point. You can kind of take that to the bank and keep it. Kiddos, with that, guess what?
We're done, yay, homework.
Done.
Done.
Done, Dylan, done.
If we have questions on 10th still,
Yeah, same.
we
agreed
can
to
go
that,
add that in to tomorrow's workday.
So tomorrow, Jackie and Gerardo come with, and the rest of you guys can text me questions at some point before class starts. Text me questions that you have on 10-3, 10-4, 10-5. Yeah, that sounds like a good plan. You guys want, I don't know if I can get it fast enough, but I'm gonna try to get you guys your homework to write down your spiral. Sound good? Okay, well, keep practice.
I wrote it. I didn't do it homework, but I wrote it.
Oh, go team. Chapter review, I might not get it up tonight, but I think all of us have homework to be doing. I'll try to get it in your Google Drive by tomorrow class. You guys want to take a picture of it? That's what we got. Nope, I don't want this.
It still feels. Misty,
So you guys actually listen up for a while?
Yeah.
Dang it.
Yeah.
I gotta figure out what Dylan's wearing. I'll wear the same thing.
There it is.
I'm so sorry. I found a brazier from the Like I had my class. I got new
Is it gonna rain?
I think everyone's correct.
I would cry if it did.
Does anybody know if it?
I think it's supposed to be like 80 degrees tomorrow.
70s, 80s.
Oh, 70s, yeah.
It's gonna be hot the rest of the week. Don't wear a suit jacket the whole time. Just, be cool, and then you can put it on in the air conditioner.
You should have like a cutting like a
Yes.
around.
Although you probably wouldn't go to a meeting like that. It could be like you've been called in for your golf with the Russian ambassador. I don't know. I'm making
But
up
the
stuff.
thing is we watched a video.
They were all in
and they're
t-shirts.
being- Yeah.
And Zach's like, no, you guys have to dress up. She's like, look at the video. See, look what they're wearing. That's what we should wear. But you guys all have to dress up. What? Zach.
As long as everyone else dresses up, because if no one else does, and then I'm in that stuff,
Well,
I'll be
you see,
it'll be
yeah. Jared's gonna come in like pants and a t-shirt. Guarantee.
Jared Ebram?
Yeah.
He's like, it's a field trip.
He's like, I'm not. He's like, to yell at, I'm not getting dressed up for this Zach.
Is he gonna lose points? What if he
What do you lose points? He's not grading us, Zach.
She'll just be sad.
She won't be
Aw.
snatching.
As long as he doesn't wear shorts. If he wears shorts, she might
If he
actually.
wears shorts, she'll go 8. She won't let him come, I think.
Yeah, she's like, you're stuck at school. Didn't he not want to come on the field trip anyways?
Yeah, he didn't want to, and then she found a way for volleyball to like, be able to come.
So we're all just gonna
What a
see
party
you
you're
at the door.
Yeah, the bell did ring, so that was.
Bye,
Bye,
guys.
Joyce.
Bye, Miss Steve.